So we are going to write algebraic expressions and equation and geometry problems, and we're going to add, subtract, and multiply polynomials in some geometry problems. So before we do that, we're going to be looking at some of our rules here. So when you multiply monomials with exponents, what we want to do here is, it's called the product of powers there. When you multiply monomials, you're going to add their exponents. So you've got a to the second times a to the third. You write down a, and you add their powers. 2 plus 3 is 5. When you have numbers and then you have variables to a power, you want to go ahead and multiply your regular numbers here together. So 3 times 2, there is 6. And then r, you're going to add the powers. You got 3 plus 5 plus 2 there is 10. So now our next one here, we've got a power of a power here. So taking a power to a power, you want to multiply their exponents. So this first one here, you got 2 to the third to the second power. So 3 times 2, you multiply a power to a power and you get 6. And so how you do that on your calculator there, 2 to the 6, you would do 2 caret key 6 equals, and it's going to tell us they're at 64. All right, so now we got x to the third to the fourth. It's a power to a power, so you multiply them. So 3 times 4, there's 12. So we get x to the 12th. A power of a product. When you have an exponent on the outside of the parentheses, you can distribute the exponent to everything inside the parentheses, provided that it's just a single term there. It's just a monomial. It's not a binomial where it's connected by addition or subtraction. So remember, those are different. This here says that you can do that. So, or you can kind of treat it as a power to a power. At each one of them there is that. So you got 2 to the first to the third. It becomes 2 to the third. X to the first to the third, that's a power to a power, so you get x to the third. What is 2 to the third? You can either put that in your calculator, 2 caret key 3 equals, or you can do 2 times 2 times 2, which is 8. X to the third. So number 2 here, we've got r to the first and r to the third, and they all to the second power. So a power to a power, we multiply those. So we get 4 there to the second, and r there is r to the third to the second power, so you're going to multiply those. 3 times 2, there is 6. And then what's 4 to the second power there? It's 16, so we get 16r to the 6th. All right, so you're going to have to decide if a certain problem involves addition, subtraction, or multiplication. So you're going to have to decide if there's polynomials given, you're going to either add, subtract, or multiply, just like we normally do. If polynomials are not given, you might have to use some kind of a formula there. So if it's area of a square or a rectangle, that's length times width. If it's perimeter, you're going to add up all the sides. If it's area of a triangle, that is 1/2 the base times the height. So let's look at this example here. From 1991 through 1998, the number of commercial C and education E internet websites can be modeled by the following equations, where T is the number of years since 1991. Find a model for the total number of commercial and education sites. So basically what they're asking us to do here, since they want the total number, because you've got the number of commercial sites and you've got the number of education sites, they want us to add them together to get the total number. So we're going to add them together. When we're adding them together here, we're going to add our like terms. So notice they're lined up really nicely for us. So we can take 0.321 t squared and add 0.099 t squared. So when I did that, I got 0 0.42t squared. And then I can take a negative 1.036t plus negative 0.120t and just add those two numbers together. So add the two negatives there together, and I get a negative 1.156, and then I'm going to write down the t. And then I'm supposed to add 0.698 plus 0.295, and I'm getting a 0.993. So example 5 here. From 1890 through 1990, the total number of people is T. So we got the total number of people there. The number of men, and there's an equation for them. Find the model for the number of women. So if the total number of men in the workforce if the total number of people there is T and the total number of men there is M, we need to find the total number of women. What are we going to do with them? We're not going to add them together. What are we going to do with them? We're going to subtract them. So the easiest way to do when you're subtracting, you have more than one number there, is to go ahead and add them together, but add the opposite of the numbers that are in here. So it was a positive, it's going to make that a negative. This was a plus, I'm going to make that a negative. This was a plus, so I'm going to make that a negative. So my calculator there, I'm going to go 0.0086 minus 0.0016. And when I do that, I get 0.007, and then I'm going to write down the t squared. All right, next one there, I'm going to do 0.087 minus 0.315. And when I do that, I get 0.228, and I'm going to write down the t. Then I'm going to take 25.375 minus 19.467, and when I do that, I get 5.908. I'm going to say W equals for women. All right, a triangle has sides with lengths of 8x plus 6, 5x minus 5, and negative 6x plus 12. So I'm just going to draw out some generic triangle here, and I'm just going to write these lengths in here. We don't really know where they go, but it helps to have them here. So you can put them wherever you want on the triangle. So then it says, what's the perimeter of the triangle? How do you find perimeter? You add up all the sides. So to find the perimeter of this, we're simply going to go ahead and say 8x plus 6 plus 5x minus 5 plus negative 6x plus 12. So then we can just go ahead and add together, combine the like terms. So 8x plus 5x is 13x, plus a negative 6x gives us a 7x. And then we've got this 6 minus 5 plus 12. That gives me 13. So there's my perimeter. So now this one here has to do with a rectangle here. It says to write expressions for both the area A and the perimeter P of the rectangle. So remember what we said at the very beginning, to find the area of a rectangle there, it's length times width, or base times height. And the perimeter, you add up all the sides. So the area here, the length and the width there are 5x squared and 2x squared. So we're just supposed to multiply those. So multiply the regular numbers here. So 5 times 2, there's 10. x to the second times x to the second there. Remember, you add your powers together, so you get x to the fourth. So that's our area. What about the perimeter? You have to add up all the sides. So there are 4 sides. We have to add up all 4 sides. So we can add those. So 5, they're all like terms there. So 5 plus 2 plus 5 plus 2 there is 14x squared. So there I have my area and my perimeter. All right, so we're going to be looking at the area of this figure here. This is a regular triangle. Remember, triangle is a base times 1/2 the base times the height. So, or some of you like to do base times height divided by 2. Here's my base, here's my height. They should form a 90-degree angle with each other. If they don't, then that's not the base and the height. So there's my base and there's my height. All right, so let's put our numbers in there, or our algebraic expressions in this case. So area there is equal to 1/2 times the base times the height. So I'm going to go ahead and multiply x plus 3 times 2x minus 1. And I'm going to leave this 1/2 until the end. So remember how this goes. You can take x and distribute it through the second set of parentheses, or you can use FOIL, first outer, inner, last. So 2x squared, x times a minus 1 there is a minus x. And then I can take 3 and multiply by a second set of parentheses there. So 3 times 2x there is 6x. 3 times a minus 1 is a minus 3. I'm going to combine my like terms. So combine those middle terms there. And then I have to distribute that 1/2 through. So 1/2 of 2x squared there is just x squared. 1/2 times 5x there is just 5/2 x. And then 1/2 times a minus 3 there is 3/2. Because basically if you need to, you can put 1s down here. So then you can multiply 1 times 2, which is 2, and then 2 times 1, which is 2, and 2 divided by 2 there is just 1x squared. And then 1 times 5 there is 5, and 2 times 1 there is 2, so you get 5/2 x. And then 1 times a minus 3 is a minus 3, and 2 times 1 there is 2, so you get a minus 3/2. All right, so we didn't talk about the formula here for a trapezoid. If you recognize that figure there, that's a trapezoid. So let me write that out. Find a trapezoid's area there, you would do base 1 plus base 2 times the height, and either divide by 2 or multiply by 1/2. It's up to you. So let's find the area of this. So area is equal to, the bases are parallel to each other. So there's base 1 and base 2. So that'd be x plus 3x minus 1. And then my height there is this right here, this 2x plus 2. So if I combine my like terms inside the parentheses there, 1x plus 3x is 4x. And now I have to FOIL this out. So 4x times 2x there is 8x squared. 4x times 2 there is 8x. Minus 1 times 2 is a minus 2x. Minus 1 times 2 is a minus 2. Combine my like terms. 8x minus 2x is 6x. And then my last thing here is distribute the 1/2 through. So 1/2 times 8 there is 4x squared. 1/2 times 6 there is 3x. And 1/2 times a minus 2 is a minus 1. So our next one here is supposed to find the volume of the box. So to find the volume of a box, you do length times width times height. So, and it doesn't matter which one you put in for each of those. I usually write if I've got a single term there, it's called a monomial there, that x is just a single term. I write that one first, and then the other two I just put next. It's easier to do the math. So fold these out over here first. Take your x and distribute it through. So x times x is x squared. X times 2 there is 2x. Now take your 1 and distribute through the second set of parentheses. 1 times x is 1x. 1 times 2 is 2. Combine your like terms. And then the last thing you want to do there is distribute the x through. So you get x to the third. Remember, you add those powers there together. And then plus 3x squared, because again, you're adding those powers together. And then you get plus 2x. So there's our volume of that box. So I can write algebraic expressions and equations in geometry problems, and I can add, subtract, and multiply polynomials in geometry problems.